Hi everyone! In the previous video, we saw how options are pretty convenient for handling errors. However, they do have a major drawback. Options don't provide any context when a failure occurs. This means that if an operation can fail for multiple reasons, then we cannot distinguish between them nor report a relevant error message to our users. So how can we fix this? Let's start by reviewing the definition of an option. An option is an enumeration with two cases, some and none. Note that I use the enum syntax from Ch03 because it is more concise, so it will be easier to compare option with other error types. As you can see, the problem with option is that none is a singleton object. It doesn't store any information regarding the context of an error. One way to fix this issue is to add a field to none. That's basically what try does. A try is also an enumeration with two cases, success and failure. Success is like some, it stores a value of type A, while failure is like none with an extra field of type throwable. When it comes to error handling, try has many advantages over options. First, the names of the constructors are much clearer. Success and failure perfectly describe what they represent. Second, throwable is a good choice to encode errors because it is a standard error type on the JVM. However, throwable is an open trait, so we can't do an exhaustive pattern match. This means that try is great when we want a program to report the error, but it's not that convenient if we want to recover gracefully. This is because we don't know at compile time which specific errors are possible, which leads to bugs and inconsistencies. This is exactly the same problem that we saw with a basic version of I/O, and the solution is also the same. Let's create a new error type called either, with two type parameters. The first one describes the type of error, while the second one describes the type of success. As you can see, either is like try, except that success is called right, and failure is called left. And also the value inside left is fully parametric, meaning that we can choose whatever we want. For example, we can create an either with a string error type, or one with a timeout exception. The fact that we can choose the error type is great because it allows us to be precise if we need to, and if we don't, nothing stops us from using throwable. So this is great, we have more options available. The downside is that we have to decide which error type to use, and as we're going to see in the exercises, it's not always clear. By the way, you may wonder why the constructors of either are called left and right, and not something more specific to error handling, such as valid and invalid. This is because either is a very general concept. It can be used in context other than error handling. For example, we could define a function getUser, which takes an either of email user ID. In this case, it means that the function accepts finding users using their email address or their user ID, so both inputs are accepted. You might also wonder why left is used for failure and right for success. It's just a convention. Scala could have done it the other way around. However, it's important to follow this convention if we want to use either within a for comprehension, because map and flat map only target the right side of an either. You will see it will become clear after a couple of exercises. So please open the file either exercises1 in the package exercises.errorhandling.either. First, we are going to implement a new version of getUserEmail. As you might remember, previously we used option in the return type, which meant that we couldn't distinguish the cause of the failure. This time around, we are going to produce a string if we can't find the email address. For example, if we call getUserEmail with ID 111, we'll get back a left with the phrase user111 is missing. This is because the map doesn't have an entry for ID 111. However, if we call getUserEmail with ID 444, we'll get back a left with the phrase user444 has no email address. This is because there is a user with this ID, but their email field is empty. Great, so I'll let you pause the video and try to implement and test this function. Okay, so we're going to start by looking up the users inside the map, exactly as we've done before. So we'll do user.getUserID. This gives us an option, so we can, again, pattern match exhaustively on it. If the user is not present in the map, we can return this error message. So we'll say user is missing, except that we're going to use a string interpolator to show which, to give the user ID value. And now, in case we do have a user, we need to check if they have an email address or not. So we can again use a pattern match because email is optional. So we can say an exhaustive pattern match. And here we say if they don't have an email, then we'll use a second error message. So we'll say user ID has no email address. And in case if they do have an email, this is a success case. So now we return a write passing the email. Yeah. Let's run the test. Let's see if it works. Yeah, it does. Cool. So now let's try to see if we can improve on this code. Let's see if we can refactor it. So it is relatively readable, but it's still very verbose for what we do. So ideally, we would like to have a nicer way to transform an option into an either, because it's probably a very common scenario where when the option is none, we want to return an error, and when the option is some, we want to transform it into a write. And indeed, there are like some combinators on option to do this. So there is 2 right and 2 left. So to be honest, I never remember which one should I use, but the good thing is that the IDE showed us how it works. So if you look at the signature of this, 2 right says that it takes a value left of type X, and it's going to return an either X email. So meaning that 2 right, what it does is that it's going to convert the sum into a write, and it allows us to pass a parameter that will be whatever is put inside the left if the option is none. So this is exactly what we want. So we'll say 2 right, and we'll copy paste this error message here. Like this. So much simpler this way. We can even put it in the same line. Now we can repeat the same process over there. So we can say 2 right, and here we're going to say, we'll copy the error message, we put it here, except that now we need to update the pattern match because now this is an either. So this will be to the left of an error. So let's say that if the first lookup fail, we're just going to return the same failure. And if it succeeds, so if we do get a user, we're going to call user.email and do 2 right. So let's run the test. Yeah, it works. Nice. So a bit simpler. Now, what I don't really like in this case is the fact that when we pattern match on this, we say, okay, if it's a left, we're going to return it exactly unchanged. And we exactly had this pattern in a previous video with option. And generally, when you see a pattern like this, it points toward flat map. So let's give it a try. So if we use flat map, we directly have access to the user. And if the first either fail, it's going to stop immediately. So it's going to fail early. And then within the inner function, we have access to the email, and we return 2 right. Like this. So actually, the code may not be, it might be shorter, but it's probably more difficult to read this way. But the thing is that once we use flat map, we know that we can refactor it using a for comprehension, which I think is going to make the code much more readable. So now, within a for comprehension, we're going to copy paste every single step. So we'll say, okay, user, and so the first line in our for comprehension, we look up the user. the second line for comprehension, we look up the email, and then at the end, we yield the email. Great, as you can see, error handling logic with either and option is very similar. We both use a for comprehension to describe the happy path, and if any failures happens along the way, the computation stops immediately. We also discovered that it's fairly straightforward to transform an option into an either using the method toWrite. To be honest, I never remember which method I need to use between toLeft and toWrite, but it's easy to find out with an IDE. Now, the benefit of either is that we get a different error message for each failure, which should help when it comes to debugging or reporting the error to our users. Depending on the use case, we can either stop here, as it's already a significant improvement comparing to options, or we can try to improve the error type. Indeed, string is very convenient to create, but not so much to test against, because we have to duplicate the error message in both the main logic and the test. As you can see here, we have to copy-paste the same error message. This means that if we decide to change the error messages in the main code, we need to update all the tests for this method. It's also inconvenient if a single error occurs in multiple locations. For example, there might be a few places in our code base where a user is missing, and ideally we would like to produce a standard error message for this scenario. So one way to improve is to change the error type from string to a custom enumeration, such as user email error. User email error is an enumeration with two possible cases: user not found and email not found. So one for each error scenario. Currently, the project is configured for Scala 2, so we have to use a more verbal syntax with Ch06. However, I added a command below to show you how our user email error would look like in Scala 3 using the enum syntax. As you can see, it will be much nicer. Okay, so now we're going to refactor getUserEmail so that it returns a user email error on the left of the either instead of a string. I'll let you pause the video and update the implementation and test. Okay, so let's update the signature first. So we're going to replace string by user email error. And in case the user is not found, so when we look up the user in the map, we're going to return a user not found error. And if the email is not found, we're going to return an email not found error. Pretty straightforward. And as you see, it compiles already. Now we'll need to update the test as well. So now this is going to be email not found, and this is going to be user not found. Cool. Let's give it a try. Nice. It works. Cool. So now that we have objects, now, for example, if we want to change the name of user not found and call it like something else, like I don't know, all the code will be updated automatically. This because we are using IDs, or at least it will stop compiling if we forget to rename it somewhere. So this is a benefit of using an object rather than a string. Now, we do want to produce an error message eventually. It can be either to put in our logs or to show it to our users. So this is why we need a function that is going to take the user email error that we just created, and it's going to return a string which is the same string that we had before. So I'll let you pause the video and try to implement the function error message that takes this enumeration and produce the same string that we had previously. So please pause the video and give it a try. Now we may want to move this method inside the trait. It will be nicer to use. So we'll say user email error is currently, it's a trait, so it can have method inside it. And then we can remove the parameter and just say this. This way we'll say, once we have an email error, we can always produce an error message. We'll just say user not found dot error message. So, and this will be quite convenient if we have advanced use cases like internationalization, where we may want to pass an extra parameter like language that will be like Japanese or English or something like this, where you would want to produce different, like the error message in different languages. That's quite an advanced use case, but that's an option at least that it is possible in this case. If you prefer, there is two ways to define the error message once you define it within the class. You can define it within the trait and do an exhaustive pattern match, or you can define it within each error class. It's really up to you which one you prefer. So let me show you what I have in mind. So we can comment this out. We'll do this. And then here you will say implement error message, and you will copy paste this. So it's really the same thing. It's really up to you. What do you prefer? Do you prefer to define the error message close to the class or at the trait level? There is no perfect solution. It's really up to you. In summary, the benefit of this approach is that there is a single place where we define the error message for each scenario. This means that our tests are less likely to break with a simple refactoring. This approach is also more flexible if we have more advanced use cases, such as internationalizing the error, or if we want to recover gracefully, because now we can pattern match exhaustively. Now, it does take some time to define custom enumeration, especially in Scala 2. So there is nothing wrong with starting with a simple error type, like string or throwable, and moving to custom enumeration later on. This is the advantage of either. We can select different error types based on the needs of our application. Great, so I suggest that we take a break, and in the next video, we'll have a look at more advanced use cases with either. Bye.